Hello friends, today we are discussing the subject microprocessor, in which the sixth unit we are discussing how do you move a data to and from the peripherals. Moving a data to a peripheral or CPU instructions that we write a data from a RAM to the memory. So SPI is greater than the data. This moves the data from the peripheral. For moving a data from the peripheral, CPU instruction leads the memory to the RAM. So X2 is the index to the why do we need the DMA direct memory access. Okay, with the DMA, a CPU usage will be the this one as shown in a and the communication rate will be. So why do we need the DM polling and the interrupts driven IO concentrations on a data transfer between the processor and a IO device. As previously we say a pooling and a interrupt both are the inefficient manner, okay, which drives IO concentration concentrates on a data transfer between the processor and a IO devices, and instructions to transfer only occurs after the processor determines that the IO device is ready, either by polling a status flag in a device interrupts or waits for a device to send an interrupt request. Considerable overhead is incurred because several program instructions must be executed for each data word transfer. Why do we need the DMA? Moving things is a waste of the CPU instructions. Instructions are needed to increment the memory address and keeping the track of how many bytes are moved. Instructions are needed to increment the memory addresses and keeps the track how many bytes are moved. A direct memory access to transfer the large block of data at the high speed on alternative approach is used called a DMA. Blocks of data are transferred because between an external device and a main memory without a continuous intervention by the processor. It's just another peripheral, but its only job is moving a data. DMA controller is connected to the internal I/O bus, performs the functions that would normally be carried out by processor when access main memory. For each word transfer, it provides the memory addresses and all the bus signals that controls the data transfers. The DMA transaction in a nutshell, a device wishing to perform a DMA asserts the processor's bus request signal. A processor completes the current bus cycle and then asserts the bus grant signals to the device. The device then asserts the bus grant acknowledgement signal. The DMA device performs the transfer from the source to the destination address. Once the direct memory access operations have been completed, the device releases the bus by addressing the bus release signal. The processor acknowledges the bus release and resumes its bus cycles from a initial position of uses of the DMA controller. A DMA controller, how its uses request a memory request transfers to the memory and from memory to the RAM to the store. So again, the RAM acknowledge for a DMA control, and a CPU sets up the memory transaction with a DMA controller. DMA controller request transfers to the memory, that is a random access memory RAM, and from that it goes to the storage. So when an interrupt is occur, a processor gives a control to the DMA, direct memory access control buffer and arbitration. Most direct memory accesses have a data storage buffer. Peripherals can send a burst of data faster than a main memory can handle. as long as it's happened frequently. Bus arbitration is needed to resolve the conflict with more than one device. Try to use the bus to access the main memory. The bus arbitration is needed to resolve the conflict with more than one device. The bus master, the device that is allowed to initiate a bus transfer on the bus at any given time. When the current master relinquishes control, another device can acquire this status. A bus arbitration, the process by which the next device to become bus master is selected and the bus mastership is transferred to it. Centralized, a single arbiter performs the arbitrations. The distributed, all the devices participate in a selection of the next bus master. DMA is possible because all the linear memory addressing, okay, the memory address space is there, SRAM is there, memory architecture as shown in the figure, high-speed bus matrix, DMA, USB FS device, mini host, peripheral as shown in a figure. Cache memory problem. Imagine a CPU equipped with a cache and an external memory that can be accessed directly by the device using a DMA. When the CPU access location X in the memory, the current value will be stored in the cache. Subsequent operation on X will update the cache copy of the X, but not the external memory versions of the X. Assuming a write back cache, if the cache is not finished to the memory before the next time a device tries to access the X, the device will remove the cell value X. Thank you friends for watching the video.